In 2024, a lot of new outboard owners are finding they're back at the dealer far more often than they expected, not always for repairs, but for scans, updates, and diagnostic checks that you can't do at home. 20 years ago, many engines could run for hundreds of hours between major service visits, and boaters handled a bigger share of the work themselves. Today's outboards promise fuel efficiency and digital control, but more owners are getting pulled into expensive electronic failures, dealer-only repair cycles, and resale losses that feel brutal compared to what the market used to look like. The industry won't lead with this, because it undermines what they're selling. But the patterns are real, and the people who see it first are the mechanics who watch what fails and what keeps running. By the end of this, you'll understand why some of the most experienced boaters are walking past showroom floors and hunting for engines that haven't been built in 20 years. The reliability collapse. The flagship models were supposed to change everything. A $77,000 Verado faced steering sensor failures in 2023 that forced boats into limp mode offshore. Owners of a newly released Suzuki 350 reported fuel pump failures before 200 hours. Yamaha's 300 horsepower V6 started throwing check engine lights for oxygen sensor faults that cost $1,400 just to diagnose. Service bulletins confirm the pattern. Warranty claims doubled between 2021 and 2023 across multiple brands. The symptoms show up the same way. An alarm sounds, the screen flashes a code, the engine cuts to half power or shuts down completely. Boats drift for hours waiting for a tow. The diagnostic process reveals a failed module, a corrupted sensor, or a software glitch requiring reprogramming. Parts take weeks to arrive. Labor costs climb into the thousands. Compare that reality to what mechanics see with older engines. A 2004 Yamaha 225 horsepower four-stroke routinely hits 3,000 hours with nothing but oil changes and lower unit service. No computer modules to fail, no proprietary software to corrupt. Just maintenance intervals that owners can handle themselves with basic tools. These older models were built when simplicity meant reliability, and that philosophy produced engines still running strong 2 decades later. The question becomes unavoidable when you see a 1990s Johnson 150 still powering commercial operations. Some of these engines have logged 25,000 hours. They're banned in certain states for emissions, yet they're still working in the Caribbean, still pulling skiers in the Midwest, still running day after day without the complexity crippling modern designs. The complexity trap. Walk into any dealership today, and the sales pitch sounds impressive. Throttle-by-wire precision, digital shift and throttle controls, integrated GPS steering, joystick docking, automatic trim systems. The screens light up with data fuel consumption, engine temperature, RPM, diagnostics, maintenance reminders. It feels like the future. But here's what the brochures don't explain. Modern outboards run on 15 to 20 separate computer modules, controlling throttle, fuel injection timing, ignition timing, shift actuation, steering input, and power trim. These modules communicate through a proprietary controller area network bus system. When one module fails or loses communication, the entire engine can shut down. Safety protocols force the engine into guardian mode or limp mode, cutting power to prevent damage. The real problem isn't the technology itself, it's what happens when something goes wrong. Dealers are the only ones with access to diagnostic software. Independent mechanics can't read the fault codes, clear them, or reprogram modules. The manufacturers guard this access carefully, requiring dealers to pay thousands for annual software licenses and proprietary scan tools. One owner experienced this when his 2022 Mercury 300 horsepower V8 threw a fault code 30 miles offshore. The engine went into limp mode. Maximum speed dropped to 10 miles per hour. The towback cost $800. At the dealer, the diagnostic fee was $450 just to plug in the scanner. The problem was a throttle position sensor. The part cost $60. Total bill including diagnostics, labor, and sensor replacement, $1,850. 6 months later, he sold the engine at a loss. Now, consider what happens with an older design. A 1999 Evinrude 200 with fitched fuel injection has no modules, no controller area network. When the fuel injectors clog, any competent mechanic can pull them, clean them with solvent, and reinstall them in about 2 hours. Parts cost around $120. Labor runs about $200. The owner pays $320 total and leaves the same day. The durability gap becomes obvious when you look at what fails first. On modern engines, it's the electronics. Sensors corrode. Modules get moisture intrusion, wiring harnesses develop shorts, software corrupts. On older engines, it's mechanical wear bearings, seals, impellers, parts that can be replaced by anyone with a wrench. But what's driving this complexity? The answer involves regulations that weren't designed with marine engines in mind. The Emission stranglehold. 26 years ago, the Environmental Protection Agency began tightening emission standards for marine engines. The goal was reducing hydrocarbon and carbon monoxide output, bringing outboards closer to automotive emission levels. Manufacturers responded with catalytic converters, closed-loop fuel injection, and oxygen sensors that constantly adjust fuel mixture. Each regulation added more components, more sensors, more potential failure points. The newest engines include diesel particulate filter systems adapted for gasoline, exhaust gas recirculation valves, and secondary air injection pumps. These systems work, they cut emissions, but they require constant monitoring, frequent cleaning, and periodic replacement. A replacement catalytic converter for a current model outboard costs $1,200 to $1,800. Installation adds another 3 to 5 hours of labor. Service intervals shortened because emission components clog faster in marine environments. Salt accelerates corrosion. Ethanol fuel leaves deposits. Oxygen sensors fail. Catalytic converters deteriorate. What used to be a 500-hour service interval became 300 hours, then dropped to 100 hours for certain checks. Owners are forced back to the dealer every season because skipping a scheduled visit voids the warranty. Contrast that with engines built before regulations took full effect. A 2005 Honda 225 horsepower has basic catalytic treatment but far fewer sensors. The fuel injection is open loop. It doesn't constantly adjust based on oxygen sensor feedback. Maintenance involves valve adjustments every 1,000 hours, oil changes, and lower unit service. Over 1,000 hours of operation, maintenance costs run around $1,800 total on a 2024 Yamaha 250. That same 1,000 hours costs approximately $6,000 in dealer service alone, not counting repairs. The complexity designed to meet emission standards is costing owners 3 times as much while making the engines less reliable. And yet, those older engines are still running. Some have crossed the 10,000-hour mark. They're not cleaner, but they're not breaking down every season either, which raises the question mechanics ask privately. What happened to the bulletproof era? Now here's what makes this situation even more interesting. The engine's mechanics trust enough to put on their own boats, tell you everything you need to know about real-world durability. But finding the right one requires knowing what to look for and what to avoid. Comment below with what you're running now or what you're considering buying. I want to know if you're seeing the same patterns we're uncovering. If this is giving you a different perspective on the new versus old debate, tap the like button, subscribe, because there is a lot more we are going to reveal soon. The golden age. Nobody talks about. There's a reason certain model years keep showing up on wanted ads. Engines built between 2003 and 2010 represent a sweet spot in outboard design. Fuel injection had matured. Electronic ignition was reliable. But emissions equipment hadn't yet strangled performance, and computer modules were limited to essential functions. These engines got the benefits of modern technology without the complexity that kills reliability. Ask any mechanic what they'd put on their own boat, and the same models come up repeatedly. Yamaha 225 horsepower 4-strokes from that era sell used for $8,000 to $12,000 depending on hours. That's not depreciation, that's appreciation. 5 years ago, those same engines sold for $6,000 to $8,000. The market is recognizing what mechanics already knew. Honda's lineup from the early 2000s follows the same pattern. The BF 150 and BF 225 are considered set-it-and-forget-it motors. They don't have touchscreens. They don't need software updates. When something breaks, it's a mechanical part that any shop can replace. Owners report crossing 5,000 hours with nothing more than scheduled maintenance. Suzuki's DF 140 and DF 175 from 2005 to 2010 are equally sought after. These engines used Suzuki's lean burn technology, improving fuel economy without the complexity of modern direct injection. The blocks were proven, the electronics were simple, parts remain available, but the two-stroke market reveals the most dramatic shift. Engines that were supposed to be obsolete now command premium prices. A 1996 Yamaha 150 horsepower high-pressure direct injection sells for $3,500 to $5,000 used. That's more than double what they cost 5 years ago. Mercury's Optimax series from the late 90s follows the same trajectory. Offshore racing teams are quietly buying them up. Commercial operators are rebuilding them instead of upgrading to new four-strokes. Charter captains, who run 8 hours a day, 6 days a week, prefer a 20-year-old two-stroke over a brand-new engine that might strand them with a computer failure. The performance difference is real. A 1998 Mercury 200 Optimax weighs 465 pounds. A current Mercury 200 four-stroke weighs 510 pounds. That 45-pound difference affects hole shot, top speed, and fuel efficiency on smaller hulls. And when the Optimax needs service, any mechanic can work on it. No dealer lockout, no proprietary software. Still, buyers need to know what they're looking for. Not every old engine is worth the premium. The warranty trap. The pitch sounds reassuring. 3 years of coverage, bumper to bumper, every component protected. But read through the terms carefully, and the limitations become clear. Miss one scheduled dealer service, and coverage is void. Use oil that isn't branded by the manufacturer, and coverage is void. Let an independent mechanic perform any work, even changing spark plugs, and coverage is void. The conditions are specific and unforgiving. One owner had his Suzuki 300 warranty denied after the engine seized at 180 hours. The reason given was oil contamination. The investigation revealed he'd used Pennzoil synthetic instead of Suzuki-branded oil. The oils met the same API specification. The viscosity was identical, but warranty terms required manufacturer-branded oil exclusively. The repair cost $14,000. Suzuki refused coverage. These experiences aren't outliers. Warranty denial has become common enough that owners now document everything. They keep receipts for every oil change, every filter, every service visit. They take photos of hour meters. They save emails confirming dealer appointments. The warranty protection that's supposed to provide peace of mind has become a source of anxiety. And when the warranty expires, the real costs begin. A failed engine control module on a current Yamaha costs $1,200 for the part alone. Programming requires dealer software, adding 3 to 5 hours of labor at $150 per hour. Total cost approaches $2,000 for a single component failure. Compare that to an older engine. A 2006 Yamaha 225 has an engine control unit that costs $650 if it fails. And many independent shops can install and program it. More importantly, these older units fail far less often because they control fewer systems. But the warranty conversation misses a bigger issue. What happens to resale value when buyers know about these complexity problems? The depreciation disaster. Pull up any marine classifieds and the pattern becomes obvious. A 2020 Mercury Verado 400R that sold new for $38,000 is now listed used for $22,000, 4 years old, less than 300 hours, 42% depreciation. The owner is taking a $16,000 loss. Now search for a 2006 Yamaha 225. Boats equipped with these engines are selling for $9,000 to $11,000 just for the engine. Some owners bought these motors used in 2020 for $6,500. They're now worth $9,200. That's appreciation, not depreciation. The market is pricing in complexity risk. Buyers know that a 4-year-old engine with computer modules and emissions equipment is approaching the point where expensive repairs become likely. The warranty is expired or nearly expired. The next owner assumes all the risk of a $12,000 engine control module failure or a $15,000 powerhead replacement. Older engines carry different risk. Yes, they need maintenance. Yes, parts wear out. But the parts are affordable, and labor isn't locked to dealers. A buyer can look at a 2004 Honda 150 with 1,500 hours and reasonably expect another 1,500 hours with normal maintenance. The same calculation doesn't Work for a 2020 Honda 150 because nobody knows when the electronics will fail or what that failure will cost. Dealers are seeing this shift in their own inventories. Trade-ins of 3 to 5-year-old engines are sitting longer. Buyers are asking more questions about warranty coverage and repair history. Some dealers have stopped accepting certain models on trade because the depreciation is too steep. This raises an uncomfortable question for anyone who bought new in the last 5 years. What's the exit strategy when the time comes to upgrade? What mechanics actually buy? The recommendations from service departments don't match what the same mechanics run on their personal boats. This contradiction tells you everything about reliability that sales brochures won't. When someone spends 40 hours a week diagnosing outboard failures, they develop strong opinions about what works and what doesn't. A Mercury dealer technician runs a 2004 Optimax 150 on his center console. He sees the new Verados come through his shop every week: fuel pump failures, steering sensor problems, engine control module faults. But his Optimax just crossed 2,000 hours. He's replaced the fuel injectors once, rebuilt the vapor separator, changed the water pump impeller 3 times. Total repair costs over 8 years, around $1,200. His shop charges $1,800 just to diagnose some of the faults he sees on current models. Another technician working out west owns 3 boats. All 3 run engines from the mid-2000s. One has a 2007 F200. Another has a 2005 F150. The third has a 1998 two-stroke 150. When asked why he doesn't run newer models, his answer is direct. He sees what breaks. The newer the engine, the more often it's in the shop for electronics issues. This pattern repeats across every brand. The people who fix these engines for a living don't trust the new technology on their own boats. They're not running 10-year-old engines because they can't afford new ones. They're running them because they know the repair histories. They see which engines come back month after month, and which ones run season after season without problems. The industry doesn't advertise this. Sales training doesn't mention it. But walk through any marina and start conversations with the mechanics working on boats. Ask what they own personally. The answers tell you which engines actually survive real-world use. So, which specific models should buyers target if they want that same reliability? The Smart Buyers List. Shopping used requires knowing which model years represent the best combination of technology and durability. Certain engines stand out because they've proven themselves over hundreds of thousands of hours across thousands of boats. For 4-stroke buyers, the Yamaha lineup from 2003 through 2010 is the foundation. The F150, F200, F225, and F250 from these years used proven blocks, reliable fuel injection, and electronics that were advanced enough to be efficient but simple enough to last. Parts availability remains excellent. Independent mechanics know these engines. Honda's offerings from 2002 through 2008 follow the same principle. The BF90, BF150, and BF225 built during this period are considered some of the most reliable outboards ever made. They're heavier than competitors, but that weight comes from overbuilt components. The valve trains are bulletproof. The electronics are simple. Suzuki's best years fall between 2005 and 2012. The DF140, DF175, and DF200 used lean burn technology that improved economy without adding complexity. These engines are lighter than Yamahas and Hondas while maintaining similar reliability. Many independent shops are comfortable working on them. For 2-stroke buyers willing to accept the emissions trade-off, the target list is specific. Yamaha's high-pressure direct injection models from 1996 through 2005, the 150 and 200 horsepower versions, are appreciating in value for good reason. They're fast, light, and mechanically simpler than any current 4-stroke. Fuel economy is competitive with older 4-strokes. Mercury's Optimax series from 1998 through 2006 represents another smart buy. The 135, 150, and 200 horsepower models are particularly sought after. These engines pioneered direct injection in 2-strokes and built a reputation for running hard without braking. Many are still running today with 5,000 plus hours. Even older carbureted 2-strokes have their place. Johnson and Evinrude models from 1990 through 2000. The 150 and 175 especially are dead simple. No computers, no electronics beyond basic ignition. They're not fuel efficient by modern standards, but they're nearly indestructible. Parts are cheap. Any mechanic can work on them. The key is knowing what to inspect before buying. Hours matter, but maintenance history matters more. An engine with 1,500 hours and documented service is better than one with 800 hours and no records. Compression tests, leak down tests, and visual inspection of the lower unit tell you most of what you need to know. Now, even perfect examples won't stay available forever. The supply is tightening, and regulations are about to make things worse. The 2026 problem. New emission standards take effect across multiple states in less than 2 years. The regulations will require even stricter hydrocarbon and carbon monoxide limits. Manufacturers are already engineering the next generation to meet these rules. The solutions involve more sensors, more catalytic treatment, more computer control, and higher prices. Industry estimates suggest the base price for a 150 horsepower outboard will start around $18,000 to $20,000 by 2026. That's roughly 20% higher than current prices. The increase pays for additional emissions equipment and engineering required to make it work reliably, or at least work long enough to satisfy warranty requirements. For buyers, this means the decision point is approaching fast. The used market for pre-2015 engines is already tightening. Prices are climbing. Availability is shrinking as owners realize what they have. Smart buyers are acting now, before the supply dries up entirely, and the only option is a $25,000 outboard that needs dealer diagnostics every 100 hours. The pattern mirrors what happened in the automotive world when emissions regulations tightened. Certain model years became highly sought after because they represented the last of the simple, durable designs before complexity took over. The same thing is happening with outboards, except the marine market is smaller and the supply of good used engines is more limited. There's also a regulatory wildcard that could accelerate this shift. Several states are considering bans on two-stroke outboards, even older models currently grandfathered in. If those bans pass, four-stroke demand will spike. Prices for good, used four-strokes from the golden era will climb even higher. The situation creates urgency without forcing panic. The smart move is researching which engines meet your needs, setting up search alerts on classified sites, and being ready to act when a good example appears. The engines worth buying don't stay listed long. They sell in days, sometimes hours. And for those who already own one of these older engines, the advice is simple: maintain it, document everything, and understand that what you have is becoming more valuable every year. The outboard industry bet on complexity. They promised better performance, better efficiency, better everything. What they delivered was higher costs, shorter lifespans, and repair bills that rival used car prices. Meanwhile, engines built 20 years ago are still running, still appreciating, and still proving that simpler engineering lasts longer. If this changed how you think about your next outboard, subscribe and watch our last video, where we talk about cheap Chinese outboards so good they destroy Japanese legends.